Hey everyone, welcome back. We're ready for section 5.2a. We're going to be starting on our trig proofs. All right, so with the last section, it was kind of hard because we didn't know necessarily where to stop. It kind of varied depending on the problem. But now that we have a proof, we know exactly where we're going to end. So here are some strategies of how we're going to work these proofs. You're going to, the proof begins with an expression on one side of the identity, and then the proof ends with the other side. So we're going to start with one side, manipulate it, change it, simplify it so that it becomes the other side. The proof consists of showing your sequence of expressions, basically showing your work. It's not, I know what I did, it's can I show how I went from one step to the other in order to come up with that simplified expression. Let's see, number 4, you may only work on one side of the proof. Okay, so we're gonna just start with one side, work it through until it equals the other side. We're gonna start with the more complicated expression and then work to the less complicated expression. So there's a little bit there at times where it's hard to tell which one that would be, but that's what we would be doing there. Let's see, and then if you don't see anything that you could do, one strategy that works a lot is change everything to sine and cosine. That helps to kind of then see how you can simplify and kind of get some stuff together. Number 7, you're going to combine fractions using common denominators. Number 8, you're going to use the algebraic identity for a difference of two squares. So when you see conjugate binomials or Pythagorean identities, there's a lot of times that we'll factor or we will multiply by a conjugate in order to get a Pythagorean identity. So that's something to keep in mind. And then always be mindful of the target expression. If you need to end up with tangent, it's not such a bad idea for you to think, well, what do I need in order to make a tangent? Oh, I need sine over the cosine. So that kind of helps you to figure out where you could get or how to get to that final answer. So let's go ahead and start off with some non-trig proofs. And I'm missing a little part here. I forgot to put the 1 right here. So basically, we're going to start with the left side, and we're going to simplify it so that we get the right side. So it's not an equation, but it's just a start with this side and simplify over here. So one of the things that I can do here is, yes, I can get a common denominator. However, I can also simplify this rational expression first. This is x minus 3, x plus 3, over x minus 3 and x minus 1. And so what I can do here is simplify top and bottom here. So now I've got x plus 3 over x minus 1. And now if I wanted to combine those fractions, I would then multiply top and bottom by x minus 1. All right, now that I've got my common denominator, I can then subtract my numerators. X minus x cancels out. 3 minus a negative 1 equals 4. So I'm left with 4 over x minus 1, and that's where I ended up. All right, same thing with b. I could get a common denominator. Let's actually go ahead and go that route. Let's say I can't simplify anything, which we know we can. And I've got x squared minus 3x. If I get a common denominator for that second fraction, I'm going to have x squared over x, which then when I combine those numerators, because I have my common denominators, x squared minus x squared is just going to leave me with that negative 3x. And negative 3x, I can simplify the x's, and I get negative 3. So I made the left side look like the right side. It's not always going to be left to become the right, but sometimes that just happens. Okay, example number 2. So we're going to show, is the function of the cotangent of x over the cosecant of x an identity for f of x that equals the cosine of x? So let's go ahead and give this a little try. So the first thing I'm probably going to do here, because I want to end up with a cosine of x, it makes sense to change everything to sine and cosine. So I'm going to rewrite the cotangent, which is the cosine of x over the sine of x. And then I'm also going to divide by the reciprocal of the sine. All right, so my numerator denominator, when I divide fractions, that's the same thing as multiplying by the reciprocal. So I'm going to have the cosine of x times the sine of x, and I'm going to then multiply by the reciprocal, which is the sine of x over 1. Well, since the sines cancel out, I'm then left with the cosine of x. So yes, it is an identity. Just kind of nice. Okay, let's keep going. Verify the following. So like for example, this one, I see the tangent of x being the more simplified version. So we're going to start with the right side. And again, you know, as I'm kind of thinking ahead, if I want to end up with a tangent, I need sine over the cosine. That would be one way to get the tangent. So maybe I should just go ahead and keep everything in sine and cosine. So I'm going to go ahead and take that right side. I've got the cosine of x, and I'm going to rewrite that cosecant as a reciprocal of the sine. All right, now at this point, I'm going to go ahead and get a common denominator for the denominator. And so that means I'm going to be multiplying top and bottom by the sine of x. So now I've got the cosine of x over, now, because I now have a common denominator, my numerator is 1 minus the sine squared of x, and the denominator is the sine of x. Now, what's nice about 1 minus the sine of x is that that becomes, that's a Pythagorean identity, that's the cosine squared of x. Here's my big fraction right here. So the cosine is in the numerator and then the fraction's in the denominator. So then I'm going to multiply by the reciprocal. I've got the cosine of x times the sine of x over the cosine squared. And what's nice about that is that I can simplify the cosine top and bottom. So therefore, I'm going to be left with what I was hoping for, sine of x over the cosine of x, which then does equal the tangent of x. And there's my final answer. So I kind of went through the steps. Next time I think I'm going to give a whole big space for this area, but there we go. So I got to write small. All right. Another thing to kind of keep in mind is sometimes you're going to get started with these problems and you're going to get stuck and you're going to go, okay, that was the wrong way to go. Let me try something else. So use pencil so that you can erase. All right, let's do this one again. So this one, again, I'm probably going to just get this in terms of sine and cosine because I know that the cotangent is going to be cosine over the sine, but it's going to be negative. So I'm thinking that's the direction that I'm going to take. So I've got 1 over the cosine of x over 1 over the sine of x minus 1 over the cosine of x divided by the sine of x. All right, so I'm going to go ahead and simplify that first fraction because when I divide, I'm going to end up with sine of x over the cosine of x. And I'm going to do the same thing with that second fraction. So when I multiply by the reciprocal, that's going to give me 1 over the cosine of x times 1 over the sine of x. So I'm going to have 1 over the cosine of x sine of x. Okay, at this point, I want a common denominator. So I need to multiply that first fraction by the sine of x, which then gives me the sine squared of x over the cosine of x, sine of x, minus 1 over the cosine of x, sine of x. So when I combine my numerators, I'm going to have the sine squared of x minus 1 over the cosine of x, sine of x. And so sine squared minus 1 looks very familiar, but it's just the opposite of what we had over here, right? And so therefore, instead of it just equaling the cosine of x, it's actually going to equal the opposite of, cosine squared. And since we have a cosine in the numerator and a cosine in the denominator, we now have simplified it to be cosine of x divided by the sine of x with a negative sign, which then makes it the negative of the cotangent. All right, very good. That's the end of section 2A.